pleasure to be here. So hello. Yes, so thank you for the introduction. I've actually got I'm going to introduce myself slightly as well, but what I'm hoping to talk about today is a little bit about me, the story of my Cambridge startup, which, as Ross has said, has got a interesting entrepreneurial journey resulting in Amazon Alexa. I'm going to talk about voice. I'm going to talk about artificial intelligence and machine learning very broadly, and hopefully there'll be time at the end for questions. There's some themes in this talk as well. One of the themes which comes up right the way through this talk is how things can grow from very small beginnings and become very big. So how difficult it is to imagine exponential growth. This is, of course, very relevant right now with what everybody's worrying about with the coronavirus. Artificial intelligence, of course, is a theme that goes right the way through what I'm talking about. And the other thing I want to talk about is startups, how entrepreneurialism, entrepreneurs are the driver for a lot of progress in engineering and technology, and how one person can found a startup, how it can grow, and how it can have a big impact. This is a topic that I'm very, very passionate about. So a few things about me. Ross has kindly already introduced a lot of this. I've got a 10-year entrepreneurial journey, which I'm going to talk about. I left Amazon in 2016, so I'm no longer affiliated with Amazon in any way. Since then, I've been actively helping startups. So I'm a very active angel investor. I'm a member of Cambridge Angels. I've invested in 79 at the moment, 79 and counting high-tech startups of various kinds. I also spend a lot of time working for this incubator called the Creative Destruction Lab that was founded in Canada but has now moved to the UK. It's in the other place. And I go there every 2 months. I go to Toronto every 2 months and help hundreds of startups, mentor hundreds of founders, hoping to do their next big thing. I'm also recently gone back to being an entrepreneur, so I have a very, very early startup myself now, after a few years, that is occupying a lot of my time. It's largely too early to talk about, but it is an AI startup, and it is doing some things that I hope people will find fascinating in time. And I was also, as Ross said, an undergraduate here. So I matriculated in 1988, which was the very first year of computer science being a 3-year undergraduate course. So I had a gap year. I came back, and suddenly there was a 3-year course. So I had to change to computer science to do that. This is me in the middle. Also, whilst I was here, I also was an active boatie. Somehow I ended up in the ladies' boat club. I was a ladies' cox. I coxed the novice first boat and the first boat. This all seems quite a while ago now, but yeah. So I'm very much part of this college. I also supervised for many years afterwards as well. I graduated with a first, and supervised for about 7 or 8 years in the supervised computer science students. So my startup. So I founded the business in about 2005. When it was started, it was called True Knowledge. It changed its name to EV later, when it produced a successful product called EV. I'm going to go through a lot of this in more detail, but we tried multiple things. This is a very common theme with startups: is you have a bit of technology, you don't quite know if it's going to work. You try something, it doesn't quite work. You try something else, and eventually you find success. It was venture capital backed. And the rest of the story we've already said 2 or 3 times, and I'm going to go into a great deal of detail. The core tech I developed myself in the Cambridge University Library in about 1999, 2000. I had about a year or 18 months working alone, sort of doing some of the core technology there. The dot-com crash put pay to founding a startup immediately, so it didn't get founded for a few more years. But in 2005, it became like a full-time endeavor. It was angel funded, then venture capital funded. And the vision of the company was a world where you could just ask computers to do things, and they would understand you, give you back exactly what you want. So, why is it that the interfaces that we have to technology are now all custom? It's a custom menu. It's buttons that are designed for the particular product. Why can't you just ask technology to do what you want, have it understand you, have it do it? Everybody knows how to use voice. This is how we interact with people. and this isn't my vision. This is a vision that we've seen for decades in science fiction. So these are some of my favorite science fiction computers. I'm not sure how many of them you can recognize. Clearly, the Star Trek computer is the most famous. And the reason why these computers don't exist or haven't existed until very recently is because it's incredibly hard to do from a computer science point of view. The computer science and engineering you need to actually build something like this is incredibly involved, and you need a lot of different technologies to make it happen. So, I mean, these are some of the things that you need. You need the computer to understand the world, understand knowledge, in order to answer questions using that knowledge. The computer needs to understand natural language for questions. There can be literally millions of ways of phrasing a single question. The computer needs to understand the world in the same way that the human does in order to understand questions, in order to reason about the world. Reasoning, inference, sometimes it needs to be able to form chains of knowledge to answer questions. You need to be able to, the machine often needs to be able to speak back. That requires generating natural language that the human user is going to need to understand. There's obviously sound involved if you're using voice. When you speak, that's vibrations in the air. That has to be interpreted as words. And the other way around, when the machine wants to talk back to you, if you've generated natural language, you need to turn it back into sound. And also dialogue. So the actual act of conversation, it often isn't just a single thing, it's back and forth. There's a huge amount of technology there. And many of these things have been worked on for decades. I was talking to Ross just a moment ago about a device from the 80s that he had experience with that was doing some speech recognition, single speaker, a few words. There were scientists that have been working on many of these things for decades, and they've improved slowly. My work and my startup's work was 1 to 5, largely. What we did inside my startup and inside Amazon was we proved that you could combine these technologies together and build something useful. And build something that's like the very first version of a computer that you can speak to that has very wide adoption. When we launched in 2005, the very first thing we did was we tried to produce a search engine that you could ask questions to. So this is the very first application of the technology. Search was very hot in 2005, so maybe we could produce a Google competitor. We produced something that was a terrible product, was really much more of a technology demo than any serious attempt to get consumers. This is the kind of thing it looked like. You could ask it a question, and it would give you an answer, and it would show in great detail the tech. So in this case, is Madonna single? It was a great test question, because if you ask a search engine that, you get stuff about single tracks sung by Madonna. And it would prove, showing you the knowledge it had used, that it could answer that question and produce a no. Another one is this one. Google couldn't answer it. What time is it at Google headquarters? And there was a long reasoning chain to produce an answer that involved about 8 facts about time zones and the location of the Googleplex. And if you type that into Google, you would get a photo essay from Time magazine because it was using keywords and statistics. So these were kind of great demos about how the technology that we had was genuinely understanding, but it was never going to be a successful consumer product. So we quickly realized that the right way to do this was potentially to sell the technology to the big search companies. So the next thing that we tried was we built a platform and allowed companies to use our technology using APIs, and we spent 2 years trying to sell that to the big search companies. We talked regularly with one of the big search companies for 2 years, and we never got to a deal. They never quite did a multi-million-pound deal with us or bought us. So we eventually moved on from that, but we did get into some smaller companies. So these are some of the companies that we partnered with. One of the ones that you'll recognize is Siri. So Siri was a startup as well. In fact, we powered a large chunk of their question answering and capabilities when they were an independent startup. But we never got that big deal. So the next thing we tried was SEO. How do you if we can't get into the big search companies through an API, perhaps we could publish tens of millions of questions and get in the easy way, which is just to have Google index the pages. Yeah, we were actually very good at that. We created a platform where basically any question that you could ask had a URL. So it had an infinite number of URLs, and would point Google at tens of millions of them. Google would index the pages. There's lots of black art involved, and we were actually very, very good at it. So this is a search you could do in 2010, which is about the time we were doing this. And if you search population of Iran 2010, we didn't just get the top link, we actually got the top 3 links. We were so good at it. And if you clicked on any of those, you got our old site, which was just as bad a user experience as the old site, except this time we'd made it even worse by adding loads of advertising to the page. And as you can see, there's a URL up there which corresponds to the question, and adverts, and we started to see exponential growth. So I was talking about exponential growth. For many, many, many weeks, we got 10% plus per week. And exponentials are quite difficult to understand and foresee. So this is a graph that we had in the early days. And as you can see, we had a freak day in the middle of June 2009, where our servers seemed to be melting. You know, we typically had 3,000 people visit the site a day, and suddenly we had close to 5,000 people visit the site a day. And the reason for that is that Michael Jackson had just died. So a load of people were asking, is Michael Jackson dead? And because one of the questions we had is Michael Jackson dead? We were getting double our normal traffic. We didn't actually answer it right, but suddenly we had this huge surge of traffic. But because we're going exponentially, that huge peak, just a few weeks later didn't look so huge anymore. And a few weeks further along, it was completely dwarfed. As you can see, if you look at the y-axis, it's now like 100,000 people a day visiting. So it's like that huge surge we had is now like 5% of the traffic we had, and it's completely lost. And then another year of that, and you get absolutely spectacular numbers. We eventually got to the point where we had sort of 7-8 million users a month visiting the site, and we were like one of the biggest sites in the UK, in the top 5,000 sites in the world. As I said, if you get steady growth, exponential growth, you get to numbers very quickly that just are very difficult to imagine. During this period, we did a fun thing. Because search engines benefit from links, we tried to generate some links by doing some PR. And one of the PR things that we did was we thought it might be fun to use our technology to calculate the most boring day in history. We had hundreds of millions of facts about the world, knowledge about the world. A lot of those had dates. So maybe if we ran a script, we could work out which day was the least interesting ever. And we did that, and we worked out that April the 11th, 1954 was the most boring day in history. We put out a press release. And that was incredibly successful. We had thousands and thousands and thousands of press articles and they were copied into different languages, and just absolutely huge amounts of press all over. Journalists absolutely loved it because they could go to their newspaper and see what happened on that day, and they all kind of agreed. They discovered there was a general election in Belgium. There was like a Premier League footballer that had died. But generally, they all agreed that this date worked, and one of the bizarre consequences of that is because of all of this press, all involving boring things and involving my name. If you Google search for my name for a long period afterwards, you got thousands of pictures of very bored people. So you can have some fun when you're doing startups, even if it's slightly on the periphery of what you're trying to do. So anyway, this SEO pivot of ours, it really wasn't true to the mission of the company. We were trying to change the interface to computers, and what we were actually doing was just publishing lots of content and trying to game Google. And this was kind of proven true because we got to like 7 million users, and then the very next month Google changed their algorithm, we lost half. So we suddenly went down to like 4 million again. And although that's still millions of users, it was very depressing, and it made it clear that this wasn't the long-term destiny of the company. So we decided that we'd pivot one last time and just go for it, and go for our own branded voice assistant. And that's what we did. So we put the company in lockdown. We got the product skills, which you can see we clearly didn't have. And we built an app, and we called it Evie. You could speak to it. It could do all sorts of amazing things. It showed off the technology. It was really beautiful. And this is what it looked like. So as you can see, we kind of solved our product skills. We launched it in January 2012. And we launched it just after Apple launched Siri. So this was very fortuitous. Normally having literally the world's biggest company as your competitor is a problem. But for us, it was incredibly helpful because they were pouring millions of pounds into this new product category, the voice assistant. And we launched just after them with our own product that was in many ways better technology, even though we were like a tiny startup. And we could do things that nobody else could do. I mean, these are some sort of show-off questions, books by Google employees, etc. But we could do lots of useful stuff, and the technology. We could also do things that nobody else could do, and capabilities that nobody else can do. So we had an incredibly busy 2012. This was suddenly very successful. We had lots and lots of press again, and we had over 1 million downloads very quickly. We were number one in the App Store. This is us being further up the App Store than WhatsApp. And we had like 40 companies beating a path, 40 huge companies beating a path to our door, different divisions of the same mega company. And when the dust settled, we had 2 acquisition offers and a big financing. We decided to get bought by Amazon. Amazon wanted to invest in Cambridge, keep the team together. So my company became a subsidiary of Amazon. It still is. It's now Amazon Cambridge. And the entire team and all our technology was then put to work on this very early top secret project, which is now called Alexa. It had a code word back then. And we then were heads down building that. Amazon built an office for us in Cambridge. They took over a building in Castle Park. This is the first one. If you look up the top right, those are supposed to be punt poles. It was Cambridge themed. That building is still there. There's now another building, which I'm going to show you shortly. And 2.5 years later, top secret work, we launched Alexa, or the Echo device in Alexa. And that was also instantly successful. Actually, to my embarrassment, I was quite surprised by that because it was really quite a clunky product in late 2014. But we launched it very, very gently. We just put out a video. You had to apply to buy it. But it took everybody by surprise. Everybody was delighted by it. The reviews were instantly successful. So this is late 2014. In 2016, I love this bit of press, so I kind of wish I could keep it up. Tim O'Reilly, who's like a thought leader in Silicon Valley, basically says that Alexa belongs in the same group as the Mac, the World Wide Web, and the iPhone as products that have kind of changed the world in terms of what's possible. So as I said, I kind of wish I could leave that one up. And it's, thousands of people started pouring into the project. There's now 11,000 people working in Amazon on Alexa. And there's now a second building in Cambridge. This is the second building by the station. So that is a wall of echoes. They theme the building on the Alexa product. So there's there's supposed to be Alexa devices decorating the wall. This statue up in the top right is an android. It's half human, half android, and it's clutching an Alexa device. I believe they've taken it away now. Apparently, it doesn't quite set the right tone, but I'm glad somebody photographed it before they did. And Alexa now, we have like absolutely enormous scale. So there is now, in 2018, they were talking about how they'd sold 100 million devices. And in 2019, they're now talking about how Alexa is in hundreds, plural, of millions of devices. So I think that includes third-party devices, but clearly, the volume of sales is absolutely phenomenal. Absolutely everybody I meet, hopefully everybody in this room has heard of Alexa, used it. I used to actually demo Alexa when I gave these talks, and there's absolutely no point now because everybody's got one or used it almost without exception. And of course, there's competition now as well. So, in particular, Google. Google, rapidly realized this was highly strategic and has produced a credible competitor, Google Home. And there's lots of people working very, very hard to dominate the market, and there's people working very hard to do it in other languages as well, other jurisdictions. And as a product category, it's also the product category that's had the fastest adoption ever as well. So this is like percent of the US market on the y-axis, and this is sort of years since introduction on the x-axis. And you can compare the Alexa type speaker, the smart speaker, with the computer, the internet, radio, television, and smartphone. And each time it gets faster, and as a new product category, it's been adopted at a rate that's very significantly faster than previous new product categories. And it's arguably also the first example of the Star Trek computer. It's like you can think of it as version 0.01 of the Star Trek computer. So I'm very proud of the fact that we've proven that you can take, as I said, this stack of technologies that you need, all the advances that have been done over the years by many people, plus our own invention, and build a product that actually has that usage, that adoption, there's still lots more to do. It's still very early. It's a long way from some of the science fiction computers that you see, in particular around dialogue. When you talk to an Alexa, it's usually, you ask one thing, you get one thing back. If there's dialogue, it's quite scripted or just one or two things. The kind of free-flowing conversation that you have with a human being isn't possible with these devices yet. There's still way more things they can do. There's more capabilities that are needed. There's personalization of the service. There's collaborating with people. There's emotion, understanding of emotion, projecting emotion, including emotion in the interaction. There's a whole load of things around humanness and naturalness. And there's also languages, of course. English is one of the world's big languages, but the number of languages you need to actually get to a very large percentage of the world's population is really quite significant. Alexa is in multiple languages now. Google's in many more. But being able to scale all of these capabilities to many languages in a very scalable way is still something where the technology lacks. And there's many things that I haven't included in the slide. So I don't want to say this is done. It's not. I see this as a kind of threshold point where it's like a product milestone where you can produce a product that's genuinely useful, but there is still way more to be done. And I think a lot of the innovation that I've talked about and a lot of the future innovation will come from startups. So I want to talk a bit to finish off about artificial intelligence more generally. So, I mean, this is a computer science lecture. Most of you already know what artificial intelligence is. It's a very vague term. It's designed to cover all the things that we think intelligence needs. So often these are very human things that humans can do that computers can't do very well. And as you know, the term is very closely associated with machine learning. Machine learning being defined as making computers learn, so improve by doing things, improve by being used, improve with data. Machine learning is why artificial intelligence is so hot at the moment, in that the modern machine learning techniques are solving problems that engineers have been trying to solve with traditional programming for 60 plus years and not succeeded. So vision is a great example. I can go to Google Photos, I can search my photo album for things that I photographed, and Google's got enough understanding of what's in the photos that they can show me all the photos of certain things in them. Autonomous driving, obviously cars, you need to be able to see to be able to drive. A lot of the advances in the pieces of the stack for Alexa that I talked about around voice, speech recognition, have been accelerated with deep learning. Machine learning has been part of that forever. You can't do speech recognition without machine learning, but deep learning has cut off quite a few years or accelerated it by quite a few years. So the data and computing, particularly deep learning, is what's accelerating that. As I said, the tailwinds are there. So this is a graph of all of the data that the human race has produced over the last few years. And again, my theme of exponential growth is well and truly there. All of our devices are producing data all the time. Every year, our devices are getting faster. We're using data-producing devices more and more. So there's this acceleration of the amount of data that we're producing. In the last 18 months, the human race has produced more data than it has in its entire history. Excuse me. This computer has been trying to, I think it's not getting any power, I think is a problem, but never mind. Hopefully this is okay. Great. In the last 18 months, we've produced more data than we have in all of history. And that's obviously driving our ability to learn from that data with these very, very data-greedy algorithms. And another thing is compute. So Moore's law traditionally means something very esoteric about the transistors on a chip, but you can take a broader view of Moore's law and talk about the amount of compute you can do with a fixed amount of money. Ray Kurzweil has actually plotted that broader idea right the way back to 1900, going through multiple technologies right through to mechanical computing. And the y-axis here is exponential. And as you can see, there is a classic exponential growth in compute per fixed dollar, fixed pound for 2 centuries. And it's still going. So the amount of computing that we can do, the amount of processing of data we can do is continually growing. So if you've got an algorithm that can exploit that, like deep learning, you can do things and continue to do things that were not possible before. And a consequence of both the data and the computing and the ability for computers to learn and do better and better is that the tech companies are taking over as well. So this creates long-term competitive advantages. This is a graph of the biggest companies in America. It's a little bit out of date, but it doesn't really matter because it's much the same now. So the left half of that circle is the bottom 282 massive companies, big cap, large cap companies in the US. And on the right is the top 5 companies in the S&P 500, which are the big 5 tech companies. And on that left-hand side, you can see that companies, these are really, really big companies, but they're kind of difficult to even see because they're pixel-sized sections of the circle. And the companies that are doing the machine learning, doing the tech, pulling in that data have just grown in market cap to the point where they just completely dominate the large companies that are out there. So this stuff is very exciting, but I think there's a broader view around AI, and that broader view is around how the advantage comes from the machine learning. It doesn't necessarily come from the statistical algorithms that we have right now, even though those problems are solving some very big problems. So machine learning is definitely here to stay. It's definitely doing things that we can't do any other way. It's solving useful problems. But the typical statistical machine learning algorithm is essentially a black box. It predicts something, it classifies something with a statistical probability that you hope is high enough for your product, and it gives you an answer. And for many things, that's absolutely what you need, but for many products, it isn't. So an example might be autonomous cars. So or compared with Alexa. So if I say something to Alexa and I'm not understood 1 time in 20, I can always say it again, and it will work, and it's fine. If you're trying to create an autonomous car and you're trying to detect pedestrians with a machine learning algorithm, 95% isn't remotely good enough. Running over a pedestrian 1 time in 20 is clearly not suitable for the product. So the context of what you need for the product is fundamental. And a lot of the applications of machine learning that we're seeing, they're creating products where that statistical success without an explanation is fine, but there are many applications where that isn't. So a good example would be Ada Health, which is a company that one of the companies that I've invested in and I advise. They are automating that first interaction with a physician. So you have a conversation about why you're sick, new questions that get asked, and at the end of it, it says 8 out of 10 people with your symptoms have asthma, and 1 out of 10 has this. And then it says what you should do next. Go and see your GP, call 999. And it also needs to provide an explanation. It also needs to explain how your symptoms, how the questions that you answer are tied to your answer. You can't do that with a statistical guess. You need to produce an explanation. You can't just spit out a result and say 88.2% probability or confidence because of a 1.5 billion parameter machine learning model. And these problems are very common. So there is a wider world out there of things that machines need to learn, machines need to grow, and there's many startups tackling this, including my one. So I'm going to leave it there and ask if anybody has any questions.
Who wants to go first?
Yes.
Have you considered...
Can we get the microphone, please, because we're taking a video record of this for those who couldn't make it and for future generations.
So, have you considered that name Alexa is used by other people and introducing it into like product which is in every home might be like problematic?
Might be what, sorry?
Like it might be problematic to call Alexa Alexa because there are other people who are named Alexa. Therefore,
Yeah, so you can change the wake word to computer or echo.
Okay, so you.
Nobody wants to.
Yeah, like.
But you can. So I'm fascinated by how successful the brand has been. Mm-hmm. So the product is called Echo. The hardware product is called Echo. So but nobody calls it that, and I find that quite fascinating. So people go to Amazon, they'll buy an Echo. It'll come in a box that says Echo. They'll take it out, they'll install it, and then they'll say, oh, I've got another Alexa in my house. And I do find that fascinating. And there are people who have children called Alex, and this causes problems, but they're loath to change the wake word to something else because they're just so attached to the brand. Yes, and obviously when we built it, we didn't know it was going to be in every home. Obviously, we hoped. So yeah, that's an unforeseen consequence of success.
Okay. If I can quickly ask another thing, where does data comes from? Like, because you said that we are producing exabytes of data, but like, is there some breakdown or how we measure this?
So the source was on the slide. It broke into structured and unstructured.
Okay.
So yes, I think if you Google the source, there was a detailed. Obviously, there's some guesswork, but I believe it. It was sort of principled guesswork behind it. Yes.
Hi, thank you very much for your presentation. My name is Marco. I run a cybersecurity firm based in London. To come to your presentation on artificial intelligence, are you first question is, are you frightened of AGI, artificial general intelligence? Because obviously, from some of the research I've done, we humans, we have goals, so we're goals orientated, so we kind of more or less agree as a society where we're going. But obviously machines, we're also into machine learning. There are no limits in terms of what these machines can do. And can you guarantee that at some point, these machines have the same goals as us? To the point where when they reach that level, they can essentially decide to wipe us out, for example.
Yeah, so, okay. So,
thank you.
So, yes. So the scenario you're talking about, people were very worried about, seemed to be a few years ago. And it seems to be, at least the press seem to be not talking about it so much. That's a theoretical, it's a theoretical big risk. But the reality is that the technology we have is a very long way away from that. So nobody knows how to build that machine that has got that such general understanding of the world that it can have goals and influence the world driven by those goals. All the technology we have right now are quite narrow applications, and some of them kind of span across multiple domains, but that ability to understand the world, reason about it, and take actions in a very general way that affects the world is a long way away, and nobody really knows how to build it. So I'm not worried about that. It could be many decades away or many centuries away.
Maybe in a slightly similar context, have you ever thought about making Alexa be able to lie? Because we all know that 100% of the truth isn't always the best way forward.
So can you give me an example where lying would be a good thing?
I was just thinking of the movie Interstellar, where they have these computers that help the astronauts, and at some point he asks a question, and the follow-up question is, what is your truth setting? And the computer replies, it's 90%. And I don't remember what he was lying about, but I think it was about the relationship of two people.
Yeah, so all of the use of Alexa, I said that these voice assistants are at the beginning right now. So if you look at all the use cases for the product, I don't think there's a single one where lying to the customer makes sense. So in the future, when we have AGI, maybe lying will be important occasionally. But right now, they're doing useful things and answering questions and controlling your house. It's never. I can't think of a use case where deceiving the customer makes any sense.
Thanks very much. Could you tell us a little bit about running a product team with 11,000 people in it?
Yeah, well, I left about before it got quite that big. So yes, no. When it became very successful, 2016, it was about the time when I decided to leave, and a lot of the people coming in were very senior. So I wasn't necessarily running a huge team. It was actually senior people piling in, which meant I was getting slightly further away from the top table. But yes, I mean, I can talk a bit about how Amazon, what it's like to work for a huge organization like Amazon. You know, when we were acquired, we were only 30 people. So I was running a 30-person team, and Amazon is run as an enormous pyramid. So Jeff Bezos is at the top, and he is the boss of everybody. And there are layers of management going down. In many cases, going down maybe 20 or 30 levels. So there is a massive org chart, and it works. You can run a business like that. You have a boss, and you have a boss's boss, and even the very, very senior people have a boss's boss's boss. I think there was a brief time when I was relatively near the top, but I went from running a business to having a chain of bosses, I got used to it quite quickly. But it's a big change, and we were in a secret project, so the project itself was relatively small, at least at the start.
Thanks. I was curious about whether you or Amazon gave much thought around the branding to how acceptable Alexa would be in terms of its intrusiveness or its ability to listen in on conversations and so on. If it was, for instance, produced by a Chinese company, do you think it would have been accepted as easily as it has been today?
Well, so it doesn't listen in on conversations. So this is a myth. When the device is not active, all it's doing is scanning locally for the wake word. So nothing's leaving the house, nothing's being recorded. It's only when you say Alexa and the LEDs go on that sound is streamed. So this is what I said. That I was kind of amazed about how successful the brand is. The other thing I'm always amazed about is how a very large percentage of people I meet think the device is listening into conversations the whole time and learning from private conversations. It isn't doing that.
Yes, I suppose so. But it does. I mean, there was a controversy about where it failed in certain words. People were then able to listen to those conversations to find out why it failed, for instance, that sort of thing. But what I'm saying is, if it was in a Chinese company, then people may not have that degree of acceptance.
Yeah, I'm not sure. I think that's right. But I think there's a fair degree of mistrust of big technology, even if they're not Chinese. At least that's my experience. It's not necessarily justified, but it exists.
My name is Andrew Armitt. You said that
you thought it would be some time before machines could, you need to build better machines in order that they might become malevolent. But don't you think that in fact that there'd be primitive operations that you could build in, and then the machine would say, I can use these primitive operations to do things that you hadn't thought about?
Yes, I wish it was that simple. So you're explaining how to build a general intelligent computer. Is that it? Or?
Well, you said that they weren't yet at the stage. You implied that you need to develop better machines in order.
Yeah, it's not. What I'm trying to say is it's not one evolutionary step away.
No, I understand that.
There's like multiple things that multiple radical new things that need to be invented before we have that problem.
Yes.
And any one of those could take decades to happen or never happen.
But I was just trying to get to the point that you could build in a number of facilities, and then the machine could discover how to use those differently from the way you thought.
If it was generally intelligent, that could be a risk.
Yeah.
Yes.
Okay.
But it's not now.
I remember sort of back in the 80s sort of looking at early expert systems and some of the new languages that came along, like Prolog, that never really kind of helped do what you wanted. And you can see that it's taken a long time for some of the infrastructure and speed and scale and things to make this possible. What are the next couple of things you think would make the biggest changes in what you're trying to do in terms of, are there any things that are near-term, let's say, technological improvements that would really revolutionize what you can achieve?
That's a really good question. If I knew the answer to that, I might be trying to build it.
Maybe you are.
It's a really good question. Sorry, I don't want to diminish the question by saying it's difficult to answer, but it's a very good question. I wish I knew the answer.
Well, perhaps you might give us, if I might ask a question myself, any ideas you have about what the useful blue sky research projects might be for PhD students who are trying to discover new science as opposed to do a startup starting next Tuesday. There's an awful lot of AI research that people do consists of collecting some data, training a classifier, and say, look, it detects some patterns.
Yep.
Without very much in the way of underlying science or even clear thought as to what the application might be.
Yep.
What one obviously tries to get students to do is to step back a bit and think and say, well, what are the bigger problems that we should be thinking about if we're trying to influence what people might be doing in engineering in 10 or 15 years' time?
Yes, that's kind of what I was hinting at the end of my talk, actually. I don't have a really clear, I can't give you a kind of clear research project or set of research projects. But I did want to make the point that we've because of recent success, we've very narrowly focused on a very specific type of statistical machine learning, which isn't suitable for many products. And as you say, there's huge amounts of excitement. There's people, pouring unstructured data into classifiers and trying to apply it to every industry. But there is but the goal is that machines can improve by seeing, by learning. If you can have a flywheel that constantly improves, you can build a product that can do things that were previously impossible. And that doesn't necessarily need to be statistical. It doesn't necessarily need unstructured data. You can learn from people. It can potentially learn from structured data. And as I say, I'm being vague. If I had a very specific set of research projects, I'd say them. But I think there is a wider set of technologies out there that is yet to be tapped into.
So I suppose that's a related question. I mean, in terms of when you started doing this, you didn't know you were going to be stood here. So was it luck, judgment, just something you loved? I mean, what sort of kept you on it to keep you there? Because I think that's probably a lot of it.
So with a startup, if you found a startup and you have backers and staff, there's a strong motivation to keep going from all the people around you who've kind of bet on you and relied on you. So, I had 7 years running it as a startup, and then of course when there's a big acquisition and your team is inside a big company, there's a huge incentive to make those 7 years count and build build a product that's going to work and be launched and be successful. Somehow I managed to keep going for a long time. But yeah, the motives there. If you're doing something really big, I think this is a theme that I'd have liked to have included, is the importance of aiming for something big. When we did that SEO pivot, we were no longer doing something big. We were gaming Google. It was kind of dirty. It was successful for a while. It made money from advertising. It got millions of users, but it was no longer that really exciting vision that we were heading towards. When we pivoted again to build this voice assistant product, Evie, we were suddenly doing something big again. We were building a product that could be used by hundreds of millions of people potentially, that was doing something new, that was genuinely useful. So I think that for me, that's what's motivating, is impact. If you're aiming for something that can have a really big impact, it's very exciting. It gets you bouncing out of bed in the morning. If you're doing something small, people are motivated by different things. There's no right or wrong answer. But for me, it's impact and doing something big that's exciting and motivating.
Towards the end of your talk, you said how there were many problems we were now solving today with AI that no amount of human ingenuity had been able to solve just with,
I said human engineering is what I said.
Human engineering, sorry.
So it's classic programming is what I meant.
Classic programming. I was wondering if you felt this trend will continue until there'll be very few problems left that people will be required to tackle, or do you think we will still find problems in the future where humans are better at designing solutions than machine learning or other kinds of AI ever will be?
Yeah, so this is very closely related to the people that were asking about general intelligence. So the fear about general intelligence is when the computer can program itself. So when the computer actually has enough understanding, it can improve itself and create a loop. The fear is you'll then get something that's infinitely intelligent and massively better than all people. I think there's a lot of false assumptions behind that view, but that's essentially where that happens. Right now, it takes human beings train a model, and that model does something very narrow. And there's no way it can actually look outside of the model and do something outside of what it's optimizing.
But less of the extreme, let's say there is now particular tasks which machine learning is just better at. Do you think that will remain, for those tasks, do you think it will remain that way forever? That is the correct way we should solve these things, and that people should not attempt to do better?
People should not attempt to do better without machine learning, yes. So take machine vision, for example. So as I said, I can pull out my Google Photos, and I can type in the word camel, and I can get all the photos I've ever taken that have got a camel in them. If you were to sit down and try and write a program that could recognize camels in photos, you would never do it. So there's no point in trying to write a program to recognize camels without machine learning, in my opinion. It's the same with voice. In 1988, I was on a voice research project, and there was machine learning even then, but there was also efforts to kind of look at features and look at, recognize fricatives by analysis of the sound using programming. It's completely futile. If you look at what speech recognition can do now, you would never want to incorporate that kind of manual programming into it. That particular problem is ideally suited for the techniques we have now, and you would never throw that away and start again with traditional programming.
Thank you.
Hi, I'm currently a genealogy researcher, personal genealogy, and I find the internet's a complete mess. Basically, you can use search to find things, but what I really want is for every individual in history to have some sort of unique ID, and every reference that really is relating to that unique person to be so that there's one unique reference number that says that is that person.
Yep.
So where I come across a Richardson, I know it's this Richardson, not another Richardson.
Yep.
Do you ever see basically the internet is everybody writes their own thing, and perhaps you could code in a little bit that said link this to a Wikipedia article. But I would really like the internet to be, if you like, indexed the way a book is, where somebody at the end has gone and said, all these Richardsons are this Richardson, and those ones are that one. Will we ever get that?
I have a deep understanding of that problem, and it's not as simple as that, but absolutely yes. So the fact that people aren't speaking, that a lot of the data is very messy and it's unstructured and entities aren't resolved to each other is a huge problem, not just in genealogy. It's a huge problem across many different applications, and I wish I could solve it.
Hi, thank you for the great talk. Just wanted to know a bit more about your new startup. Like if it's
I was wondering whether to mention it at all, or not to, or just to say that I was doing it and say it was still a mystery. And I decided to mention it and say it was still a mystery. So it's called Unlikely AI. It has a product that you can try, which is not really what the business is doing, but it's fun. It solves cryptic crosswords. So it's a great example of an AI problem that deep learning would be pretty useless at for all the reasons I mentioned. In that you need an explanation, you need to be able to explain how it works, you need to be able to reason. So it's a very interesting test environment for some ideas in natural language understanding. It's never going to be a huge. That product is never going to be a huge thing, but it's a very interesting test environment for AI. In the same way that DeepMind started with video games. Clearly, video games are never going to be a huge. Computers playing video games is not exactly a world-changing application, but it's a very interesting test environment for the machine learning that they were doing. And we're also working on a platform that's way too early to talk about that can power that and can power other things. So that's about as much as I can tell you right now. We're very early. Most of what we're doing is still not announced. But that might change in the future, in the near future.
Well, do we have any last questions? If not, then let's thank William for an absolutely splendid, distinguished lecture.
Thank you.